All right, so now that we have understood this property of composite numbers, that they always have a smaller prime factor as compared to their square root or equal to the square root. Let's see a justification for this property, why this is true. So let us consider the composite integer n. By definition, it's going to be a product of other numbers because it's composite. So let's assume that we have two factors of n, which are p1 and p2, such that their product becomes n. Okay. Now it's quite possible that one of or both of these factors are not prime themselves. Okay, because sometimes a number n which is composite has more than two prime factors. So in this case, we are considering only two factors, so these factors may not be prime themselves, but that is not a problem, as we will see in the next argument. And we assume that both of these factors are greater than 1, basically. So the idea is that one of these numbers p1 and p2 has to be less than the square root of n. For example, as a contradictory argument, we can say that if both of these numbers are bigger than square root n, then their product will of course become bigger than n, which means then they cannot be the factors of n because their product has become bigger than n, because their product has to be n. So it means that one of them has to be smaller than square root of n. So in this case, let us assume that one of those prime numbers is smaller than the other one, and it so happens that the number p1, let's say, which is the smaller one, is not a prime number itself. Then we can break it up into smaller prime factors, and the smallest of those factors of p1, of course, will always be less than the square root of n, because p1 was less than the square root of n because of this argument to maintain the product to be less than n. So this is a hand-waving argument as a justification of this property.